Hello, hi everyone. I see that people are still joining. The count is going up. Welcome to this webinar today about drone technology and 2D and 3D digital data for inspection of assets. We're joined by Ian from ProDroneWorks. This is a webinar organized by IWFM North and the Technology Special Interest Group. I'll let Ian introduce himself.
Hi everybody, I'm Ian Tansey. I'm the Managing Director of ProDroneWorks. Thanks for the introduction, Harry.
I'm Harry Milonadis. I'm Head of Technology for ENS International FM, and I'm also a member of the Technology Special Interest Group. We organize webinars like this and produce data and information about technology in FM. In today's event, we're going to be looking at the benefits of drone technology and some case studies. Ian has some great examples to show us, including some interactive videos and point clouds and other surveys they have done with his company. If we, the next one. And IWFM North will be doing several events throughout the year, mainly online at the moment. Hopefully in 2021, there will be the opportunity to start doing events in person as well. I'll hand you over to Ian now to take us through his presentation and all the information.
Thank you, Harry. Thanks very much for the introduction. Good to meet everybody. So, as I said at the start, my name is Ian Tansey and I'm the MD of ProDroneWorks. We established the company roughly around 3.5 years ago. Primarily, we were focused on using drone technology to kind of capture digital information on assets and projects. And since then, we've expanded out our offering to also cover mobile mapping, which is used in roads, infrastructure projects. We also use terrestrial laser scanning. So we've become like a digital kind of inspection and surveying company using different types of technologies to capture this information. So yeah, we don't kind of really pigeonhole ourselves into using one sole technology itself. What I'll do today on this presentation is I'll bring you through the different types of technology can be used and primarily focus on the benefits and how the technology can be used on different projects and bring you through a lot of kind of case studies. So I'm going to make this session as interactive as possible. I'm not going to kind of read slides for the next hour. I don't have any notes prepared, so this is all off the top of my head. I have prepared for it as well as that. I will show you kind of some live examples of where we've used the technology in different ways, which I think you'll get a lot more benefit out of rather than kind of just using kind of static slides. I'm going to turn off my webcam now, save a bit of bandwidth because a lot of the outputs that we deal with are fairly large and complex. I'm just going to save a bit of space. What I'd also say as well is if anyone does have any questions, feel free to ask us during the presentation and through the slides. It would be better to do that rather than having all the questions kind of at the end. So yeah, if anyone's any questions, just I think raise your digital hand and we'll try and answer them. Brilliant. Yeah, so as I mentioned, we've become a digital surveying and mapping company. We primarily focus on 3 kind of key sectors or segments of the market. We work with large kind of tier 1 construction, infrastructure and asset inspection companies, using a combination of aerial technology and kind of terrestrial based technology. So as I mentioned, we use terrestrial laser scanners, we use helicopters on some jobs, we use mobile mapping, and we also use drones, hence our kind of our name. But these 2 technologies can be used in different ways. So essentially we need to think about these technologies as like a digital data capture tool. A lot of them produce kind of similar outputs. They produce point clouds, Orthomosaics, maps, etc., which we'll cover off as we go through the presentation itself. But they can be used in different ways for measured building surveys, for the assessment of projects. They can be used for space planning, facilities management. They can be used for like progress monitoring on a project. They can be used in so many different ways, like any MEP type service as well. So building control plant, and digital footprints, topographical surveys. So there's loads of different ways that the outputs can be used. And what we can do also then is we can actually kind of produce CAD and Revit models as well. So a lot of people probably don't realize that with the digital outputs from drone technology, they also can be converted into CAD in 2D or 3D or any type of Revit models from like LOD 400 all the way down to 100, and we can embed asset information within that. That's particularly useful when it comes to, say, facilities management. So like if you have like an asset, let's say like it's a school, let's say it's an NHS facility, like a building, we can scan those elements, we can model them, we can create a Revit model, and then we can embed asset information. So you could use them for facilities management purposes. So if you're looking at a particular piece of infrastructure, let's say it could be a controller on a heating panel, etc. You want to find out, when was that last serviced? What's the model number of it? What's the the operations manual? A lot of that information we can embed within the models that we create, thus saving clients a lot of time and money. But yeah, these are some of the kind of high-level benefits of using drone technology. I'll go through them very quickly, but what I will do is I will touch on them as we kind of go through the presentation itself. So, the first one, cost savings. There's big cost savings when it comes to using drone services and solutions. They can be more economically beneficial than using kind of traditional methods. So, it is cheaper to carry out a drone survey versus, let's say, a terrestrial laser scanning survey. There's also, big time saving elements. So like a drone survey can be done very, very quickly. For the vast majority of drone surveys, like we can carry them out within a single day. Whereas on let's say using traditional methods like terrestrial laser scanning, it could take, a week, 2 weeks, etc. So like a good example is like we worked on a big project. It was a 20-acre site for a client. It was a number of different buildings with different types of equipment on site. We carried out a terrestrial laser scanning survey of that site in 15 days, whereas we carried out the same survey using drone technology within a day. So there's massive time savings there. Again, there's pros and cons to using both, and we'll kind of touch on that as we go through this. Another key advantage is there's unparalleled access. So like drones can be used to inspect any sections of a building or a structure, where that isn't the case really with kind of traditional methods. So like a valley of a roof, a slope, etc., without putting people at risk. So like, if you're inspecting, say, their roof or a facade, a cherry picker can get you to, say, like different access or different points on a survey or on an asset, whereas with a drone we can pretty much fly anywhere across that access using cameras and using different scanners. And then there's also improved data quality. So by providing enhanced field data, we can significantly improve the quality of the client's business process. So a lot of the information that we produce, the digital information, can be used by the on-site, off-site teams, and then it can also be shared with your end clients, and it can be used by different teams to collaborate on projects. So like health and safety can use it. It could be used for site inductions. It can be used with subcontractors. So there's loads of different ways you can use the information. The accuracies as well are very important. So typically with drone surveys, we can get accuracies down to 20 to 30 mil on the X and Y, and around 30 to 40 mil on the Z value. If we were to use a terrestrial laser scanner, the accuracies will be probably within the 10 to 20 mil range. So there are differences in the accuracies, and obviously there's massive risk avoidance, and then there's health and safety benefits as well to using drone technology. Like, so we did a survey probably like 2 or 3 months ago, facade and roof survey on an NHS facility, and we surveyed that within a day. There was massive health and safety benefits. We didn't need to put people at height. We didn't need to put people at risk by working at height, and we were able to survey and assess the condition of the roof and all the elements of the roof and the facades very, very quickly and safely. This is an example here of one of the digital outputs that we produced. It's called 2D Orthomosaic. For those that aren't familiar with the term Orthomosaic, essentially this example here is we flew a project in central London, and we had very, very limited access to the roof facility or the roof area. We were only able to access this kind of central verge here. From that area, we were able to fly the drone and capture high resolution images of the roof area. An Orthomosaic is created from the hundreds and thousands of individual images that we collect on the survey, and those images are stitched together using software. It's called Photogrammetry software to create a 2D orthomosaic. And a 2D orthomosaic is ortho-rectified and it's georeferenced, which means it can be used in any AutoCAD, GIS, or BIM type system, and you can take measurements from it. So if we wanted to take a measurement in terms of, what's the overall width or height of something, if you want to calculate areas, lines, etc., all of that can be done from these 2D orthomosaics because they're all ortho-rectified and georeferenced. And they're a great way as well to do comparisons over time. So if you have a facility where you want to do, say, regular checks, you can compare two of these orthomosaics, say like two, you can compare 2, 3, 4, and you can compare yearly, quarterly imagery to ensure that there's no kind of defects occurring on a roof or on a facade over time. So it's a great way to kind of check the facility over time and ensure that there's no defects or issues happening. And what we can see here is an example of the green lines are essentially a 2D DWG CAD file. So from the digital outputs that we create, we can create a 2D CAD drawing. And the only way to create this 2D drawing was from a drone survey, from the digital outputs we created. Traditional surveying methods wouldn't have been able to capture this information. So it's an ideal tool to capture the information that's required from a client. So I just kind of switch screens and show you what the actual 2D orthomosaic looks like, and then what the CAD drawings look like as well. So this is a large facility that we surveyed a couple of months ago. And what we did was we flew the drone right across this whole roof. We captured something like 1,500 high resolution images in total, and then we used photogrammetry software to stitch all of those images together to create this one single image. So you can see here, this one single image allows me to go across the whole facility in high resolution, and so I can keep scrolling down and down and down, and you can actually see like some of the areas where there's moss on the roof. You can see air vents. You can actually see some of the air conditioning units over here. So it's a great way to see in detail the whole facility. So I don't need to scroll through individual images. I can scroll through one single image, and it gives me a great understanding of the condition of the roof. And again, like this could be a great way if you're collaborating on a project. So let's say you're a facility management company, want to look at the condition of the roof, you could do it with that. Let's say you want to get some work done, so you want some subcontractors to price different pieces of work. You could share this with them. You could say, well, there's defects here, here, and here. So they could set up the scaffolding only where it's needed, which results in massive cost and time saving. So like carrying out a drone survey before you decide what work needs to be done is a great kind of time and cost saving element, because you can then target where you need the works to be carried out. And I'll take a scroll down here. You can see like the level of detail is quite good. And again, if we wanted to use this to take measurements, we could. If we wanted to calculate, you know, the width, height, depth of this grill area, we can here. If we want to calculate the area, that can all be done. And then you can also see here this slide. So this is the DWG file from the roof survey we did. So you can see here the DWG file or the CAD file overlaid on top of the Orthomosaic. So you can see all the line work that's taken place, and it gives you all the different values. So again, this can be used for kind of planning, design work by an architect. It could be used for like a planning application as well. It's very useful. So we go to the next slide. What we can also do as well is we can produce Google KMZ files. Essentially what they are is we take the 2D Orthomosaics that we've created and we produce a Google friendly format. So what it does is it gives us context on a facility. So like this is a big project where we surveyed something like 800,000 square foot of roof across these 3 different roof elements. And the client was using the information for a conditional survey of the asset itself. So I'll show you what the actual Google KMZ file looks like. Yeah, so this is it. So you can see here I can turn on and off. This is the Google Earth image. As we all know, Google Earth, where you scroll in and it loses resolution. So when I turn on our image, you can see the level of detail. Like I can keep scrolling in, keep scrolling. Just give it a minute to update. You can see the difference between the two maps. So there's quite a contrast between the two of them. Like what our client was using this for, not Google KMZ, but the other file is they were even able to see some of the rebar coming up, you know, through the concrete, which they probably wouldn't have noticed as much when they were looking around at the actual facility itself. And again, this can be shared with, you know, your on-site, off-site teams. It can be used as part of the conditional monitoring, maintenance checks. You can start to see progress of changes over time. What we can also produce then is point clouds. So a lot of people are not familiar with drones. So you know, they all think that drones can only be used for photographs and images that can be used in a marketing environment, but they can also be used to create 3D point cloud information. So this here is an example of what that point cloud information looks like. And again, this is a survey we carried out for a client where access to the roof and facade areas was very limited. Traditional methods wouldn't have been able to get access to all parts of this roof area. So the client wanted to use this drone technology to survey the whole roof area and produce a Revit model. So essentially what they wanted to do is they wanted to use a Revit model for planning and design purposes to install solar panels on the roof. So if you imagine, you know, you're planning how many solar panels can I get on a roof, what size can I get on, how many of them can I get onto the roof area, etc. That's very hard to do without having measurement information. And using a drone, we can provide that information to our clients, and then we can take this information and produce a CAD or Revit model. So I'll just show you here. So essentially, it's a 3D point cloud, and eventually we get down to the individual points. So like we can scroll around any single part of this site, and we can take measurements. So if we wanted to measure the top and the bottom of this, we can do that. If we want to measure the width, that can be done. You can see it up here. It gives us, the measurement 7.2 meters in total, and it also gives us XYZ coordinates. So you should be able to see down there the XYZ coordinates, which are all tied into the OS grid. We can scroll around any part of this project, and we can zoom in. We can see the actual air conditioning units, and we can measure those, and we can also take this information and produce a Revit model, which looks like this. So this Revit model was created to, I think it was LOD 300 and a mix of 200. And what we can do is we can look around the whole facility. It's all coordinated into the OS grid. And what this allows the client to do is it allows them to plan and see how many solar panels they can install on this roof area. So eventually it's all correct. You can also embed asset information within this also. Do we have Harry, questions so far?
Nothing from the audience yet.
Nothing yet. All right, brilliant. Keep going. And yeah, this is the Revit model that we just showed. We can also produce like 3D textured models. So like, again, these are all in 3D, and they can be used for like collaboration on projects. You can scroll around, zoom in and out on any element of it. It gives context and texture to a project. We can also do like aerial 3D animation and augmented reality on videos. So I'll show you here what that actually looks like. So this is an example of where we would have flown this project using a drone, and we would have taken the drawings from the client to create these 3D models. And what we can do then is we can render the 3D models into the video itself. So it gives you an understanding as to what a project will look like. So this could be great from a planning perspective. If you're going for a planning application for an extension on a roof or a building, etc. It could be used in this. Gives planners a great idea as to what the actual facility would look like. And it can also be used for it's kind of primarily infrastructure projects, but we can include whole roles. So essentially, what we can do is we can take any type of aerial video, and we can include any type of augmented reality or 3D animation that you want. It could be, an extension to a roof, modifications, etc. And then this is an example again of kind of an Orthomosaic and what it actually looks like. Again, very similar to the one I've showed previously. Where you can take measurements, you can see in one single image what the facility looks like, and then you can start to do comparisons over time, because each of the images that we capture are all geotagged. So if you want to look at one particular area, you can relate back to the same area from a previous time period. And then these are examples of what the actual high resolution images look like, and I'll just show you kind of an example of that. So you can see here, like this was a project we surveyed in central London, and it's a good point on the central London. We can fly pretty much anywhere within the UK, so ProDroneworks has a special OSC license from the CA where we can fly within 10 to 20 meters of buildings, vehicles, projects, people that are outside of our control. This is an image from one of the cameras that we use, so you can see like the level of detail that can be captured. So as you can see here, missing slate tile missing. You can see there's defects right across the area itself. So like this information is kind of really as good as being there in person. You can see here a huge amount of cracks and broken steel work, right across this facility. You can see again here, lots of defects. A lot of these defects wouldn't have been picked up had you not been using the drone, or it would have been very expensive to use a cherry picker. Cherry picker not to give you access to all elements of this. And if you're in kind of a central location in, say, like Birmingham, Manchester, Liverpool, etc., you're going to have to get a permit from the council to set up a cherry picker on a road where you don't need such permits when using drone technology. What we're starting to do as well is kind of push our clients towards using cloud-based platforms for kind of sharing, posting, collaborating, analyzing the information. Like we do an asset survey, typically we can capture a couple of hundred, 1,000 images, and how do you actually go through those individual images, and where are those images actually taken? So like if you have a big roof area or facade, and it's quite similar in terms of how it looks, between one area and another, how do you actually know where the image is taken? So a cloud-based platform allows you to do that, and this is quite a good video here which shows that process. So this is a project we did for one of our clients. So this is actually an NHS facility, Barnet Hospital. And you can see here on the left-hand side of the image, these green dots represent individual images that we took with the drone. And what it shows you as well is the arrow. So the arrow is the direction in terms of where the image was taken. So what this does is it allows you to kind of clearly see, where on the building the image was taken and what was the orientation of it. So it gives you context. What you can also do as well is you can insert annotations. So, here in this example, we can see that there's a lot of vegetation in the gutter. So we can kind of tag that. We can give it a different level of severity. So you have different areas there from 1 to 5. And it also gives you the ability to enter any text that you want. And then you'll see on the left-hand side that dot goes from green to red. That signifies that there's some type of defect. You can see on this example here, again, we have some ridge cap missing. So we can highlight the area, and again, we can write that into our annotation or our notes. And the really benefit about this is that you can have different people within the organization having access to this information. So like with everybody working, or with a lot of people now working remotely, you could have different levels of access to the information. So you could have a team based in Manchester, Liverpool, London, Bath, Bristol, etc. Collaborate on this project. Everybody having access to the information, and the information then being shared with subcontractors. So once you've gone through all the individual images, what you can then do is you can produce like a PDF or an Excel document which has all of the defects highlighted on it. And those defects can then be shared with subcontractors. So if you have a surveyor who's gone through all the information, they've highlighted all the issues. You can then share this information with subcontractors. They can price the work accordingly. You know exactly what work needs to be done. And then what you can do is maybe after the work has been carried out, you could do a second flight where you could fly the same facility and ensure that all the work is carried out as it should be before you hand over any money to the individual subcontractor itself. So it's a great way to kind of validate quality control checks on a project. And then you'll see here, it gives us the ability to generate PDF report. And then I'll show you what that PDF actually looks like. So this is an example of that PDF report. So you essentially have an overview of the roof itself. You have the 3 red dots which signify the defects. It gives you the severity levels. It gives you a summary of each of those issues that we've identified, and then it gives you an individual page with a high-level overview image, and then kind of a more zoomed-in image as well. And again, that could then be shared with the subcontractor so they can price up the work. We can also use thermal imaging to identify leaks. And so like we're obviously coming into the winter season where there's going to be a lot of rain. And during that period we get very, very busy carrying surveys for clients where they have leaks. And what a thermal imaging camera does is it allows you to identify areas where there's water ingress, let's say underneath the membrane, which wouldn't be visible to the naked eye. So in this example here, we can see 4 individual areas where water has ingressed in underneath the membrane itself. So it's a great way to identify or to be used for kind of leak detection. And this is an example here where thermal imaging can be used for like heat loss detection. And this is a great example here on the top left, so you can actually see the roof itself. And the image on the right hand side shows us the areas where there's heat loss. So we can see like along the top of this ridge cap here that there's a heat variation. So that roof should be a consistent, say 12.5 degrees. And we can see along the top of this roof here that it's just over 17 degrees, which signifies that there's heat escaping. And then you can see another example on the bottom left hand image. Again, a kind of the same building. On the facility where we can see various different heat spots here. Again, this roof should be a constant, say 10.5 degrees, but we can see big variations here when it comes to elements in the roof where there is heat escaping, and it allows us to identify where those areas are. Solar panels is another area where thermal imaging can be used. So like a lot of facilities now are using solar panels on roof areas, and how do you actually check that those solar panels are actually operating efficiently and as they should be. So again, access is not an issue with a drone survey. We have a special thermal imaging camera that we attach to the drone, and that thermal imaging camera will carry out an assessment of these solar panels and then identify panels where there's defects. So we can see here there's clearly one solar panel on this roof that's defective. It's very, very hot at just over 20 degrees where it should be kind of like a constant 15 degrees. And we've had instances as well on some projects where a client has installed say 50 new solar panels straight out the box, and some of those solar panels were defective. So like there was one project where a client had 50 solar panels installed on the roof, and they asked us to carry out an assessment of it, and we identified 3 of those solar panels were defective, and they were able to claim back under the warranty from the manufacturer, and they were able to use our reports for that. And then these type of surveys can be carried out on a regular basis to make sure the solar panels are operating properly, because if they're not operating properly, you're losing money because of it. This is a great example of where we've used terrestrial laser scanning on the internals and externals of a project.
Before we go into laser scanning, there's a couple of questions that are quite interesting and relevant to what you covered. We saw quite a few places where not only commercial, but also domestic properties are being shown. Is there any concern about privacy and when pictures are taken in case something else is captured?
Yeah, no, it is a question that comes up, quite often, that people are concerned about, data privacy. But data privacy only really affects companies and individuals and peoples when there's actually a link between the actual images that are taken and information itself. So, like, let's say, for example, we're in central London, we're taking photographs. So I'll go back to one of the previous. Yeah, so this is a great example here. So, like, we're surveying a roof in central London, and
Sorry, Ian, you've gone quiet again. Can you just move your mic for us?
Can you hear me?
It's very quiet.
Can you hear me okay?
That's better. Perfect.
Yeah, not sure what's wrong there, but you can see on this example here that we've picked up, the body of an individual. That could be the head of an individual. Privacy only really comes into effect when we link or know who that person is. We know their name, we know their age, we know their date of birth, etc. If we're taking pictures of a roof facility, and somebody happens to be walking by, like, we don't know who that person is, we don't know their name, we don't know their age, we don't know their date of birth. We're not linking any information to the actual image itself, so privacy doesn't really come into effect. If we started to take images and then know that that's Joe Bloggs, he was born on the 21st November 1926, well, then you will have data privacy issues. But it's no different to somebody standing on the side of the street and taking photographs of of people walking by, unless there's a linkage between personal data and the images itself, it doesn't become an issue.
So that brings to my mind the question about ethically, if, for example, you're doing a survey and something happens and later on you need to disclose some information or images or video, maybe there's an accident or something and the drone might have captured some footage. Is this something that the clients need to be aware of? Does it need to be written somewhere or mentioned?
It's not something we've come across in the 3.5 years we're here, but yes, obviously, there would be discussions between us and the client about, let's say, if there was an incident on site, the client might come to us and say, like, did you pick up or do you have any video or images on that? But we wouldn't share any information on a particular project without the client's authorization. So we would notify them and get their permissions beforehand. It's never come up as of yet.
Okay. And one more question. You showed some use cases. Have you ever been asked to check for pest control? Use drones or thermal imaging for pest control and pest inspections?
No, never for pests, but absolutely it could be used for pest control as well. So, like, if you have areas on the roof, let's say, for example, where there is vermin getting in, a drone survey and the digital information that could be produced could identify areas where maybe the vermin are getting into it. So it can be used in that way, or it could be used to, let's say, for example, look at where seagulls or birds are nesting on a particular part of the survey as well. So yeah, it could be used in those instances, but we haven't been directed by a client for that particular purpose.
Okay, great, thank you.
That That's all the questions, Harry, is it?
For now, yes.
Yeah. Right. What I'll do is I'll come back to the laser scanning. That's where we so I'll just show you an example now. Terrestrial laser scanner. So like there are instances where it's not practical or appropriate to use a drone service. So if you want to do like an internal survey of a facility for like MEP facility management purposes, you wouldn't really use a drone to do that, although you could. So we would use like a terrestrial laser scanner. And this is an example here of what that looks like. So this is like a sludge building on a water treatment works. So you can see here we have a huge amount of information both inside and outside of this facility. And a lot of clients are actually using this to kind of like understand about projects and assets. So like rather than having, let's say, colleagues visiting site repetitively to take measurements or even just to look around and understand the condition of a building, you can go in, or we can go in, we can capture all this digital information at once, and then that information can be used by various different departments to understand a building or to navigate around a building without having to visit site. So there's huge kind of time and cost savings when it comes to that. So you can see here we can very clearly, you can see all around this facility. We can go inside as well. So like our laser scanners were inside this building and capturing information in high detail. So we can scroll across any part of this site or this building. We get a huge amount of information. Again, we can take measurements from it, but even if it's just to kind of walk around the facility, understand it, what pipes are there, etc., we can do that. And then we can, as I said, we can take this information and we can convert it into a Revit model. And I'll just show you a video what that actually looks like. This is an example of a video where we've taken a point cloud using our terrestrial laser scanners, and then we converted it into a Revit model. As I mentioned, we can do it from LOD 100 down to 400, and then we can embed asset information within it. So this could be great from a facilities management point of view. So if we have different features or elements in this project that we want to embed asset information to see when it was last serviced, what model number is it, when it needs to be replaced, the operations manual, etc. All of that information can be put and embedded within these models themselves. So you can see there it's quite realistic, and it can be used by different departments for different reasons. And then we also have not just the point cloud information, but we can also look at 3D images. So this is here an overview of that actual building itself, and each one of these triangles represents an individual area where the scanning was taking place. What we can do is we can double click on it, and then we can view and scroll around the facility. So it gives us a great idea as to what's in the building. We can skip or just jump to another one of those arrows, and it gives us a perspective from a different angle. as I mentioned, a lot of companies are using this, are using us to survey a site, so they don't have to have their colleagues going back to site again and again and again, so they can jump around the facility, see what's there. They can take measurements from it, so it gives them a great understanding, even in terms of, we can scroll in on some of the images, gives us a great understanding of the condition as well. This is kind of one of the standard outputs that we produce. And then these are examples of Revit models. That's pretty much it from me. Is anyone any questions at all?
Yes, we have a few questions. So a follow-up to the pest question, is there also any possibility to use drones to sort of eradicate any problems, or at least divert them in case of birds or something like that? Would you come across?
Not really. We've had one or two inquiries from clients about using drones to wash windows. So you have like an arm on the drone which washes windows that are up at high levels. Again, it's something I've seen being developed, but I don't think it's quite there yet. I'm sure there probably will be features on drones in the future that'll eliminate or allow ways to kind of eradicate vermin and pests, but not as of yet, like blocking up holes, etc. But I'm sure it's definitely going to happen in the future. No doubt about that.
Okay. I have some more technical questions, and then we can go into some more high-level questions. So what accuracy can be gained for pipework and equipment? I think maybe if you explain the different level of details that we can get in BIM and when we do scanning.
Yeah, so like this on this example here, like this is a drone survey, point cloud. So the accuracies, the relative accuracies on this are around 2 centimeters, 2 to 3 centimeters. So if I want to measure the width of this air conditioning unit, I know that it's going to be accurate to probably within 2 or 3 centimeters. Now, if we were to switch to, let's say, terrestrial laser scanning, which is this here, the accuracy on this will be kind of like, say, sub 10 millimeters, so sub 1 centimeter. So there's a bit of a difference when it comes to the accuracies, but again, it's all about why the client wants it, what are the reasons for it. So different technologies can be used in different ways for different levels of accuracies, and that helps.
Thank you. And once the scan has been done, is there which ways do we have to share what we've captured with clients, and is it easy to prepare those, if it's a fly-through or a 3D model or something that the clients can use as an end product?
Yeah, again, it kind of depends on, I suppose, what software the client has. Like the easiest way to share it is by in the cloud. So like we have, like what I showed you with the roof inspection for the NHS hospital, like that information can be shared in the cloud with the client, so you can give the client access to it through a web browser. So that could be done with like a drone survey, or it could be done with a terrestrial laser scanning survey as well, like what you can see here. So like what we're starting to do is kind of push our clients towards using cloud-based platforms for like hosting, storing, sharing all that information. And then like a few of our clients have raised concerns about like where is the information stored and hosted. Like they don't want it being hosted in the US. So like we use kind of UK-based servers to host all of that information. So it's all kept here, and then the client gets easy access to it. So you'd essentially, like, you would share the web link, and you'd give them a username and password. They will be able to access the information. They don't need special types of PCs or hardware, which can be expensive.
But from your side, you need to prepare. Are there ways to create something quickly and cost effectively, or is there work that needs to be done after the capture?
No, that could be done very quickly. So like once we've produced the outputs, we can put them up in the cloud, or we can put them on a Google Drive for clients very, very quickly. So there's not a huge kind of time gap or time lapse.
And I think now, we're talking about how clients can consume this. The natural question is, how much does it all cost? How is this priced? That goes for both drones and laser scanning.
Yeah, like as a rough idea, like every project, no two projects are the same. So like, there are different sizes, different deliverables, different levels of accuracy. But to give you a rough idea, like a drone survey of a facility, you want to produce 2D, 3D outputs, could be anywhere between say 2,000 and 3,500 per site. And if you want to say like just pure marketing images and video of a facility, or if you just wanted to do like an inspection of a facility, that could be anywhere between £1,000 and £2,000. If you want to do like laser scanning of the internals of the building, again, it's very hard to say like how big is the building, how many floors, etc. But like just to give you an example, like this survey we did here, this was
if we say plant room, for example, or something like that.
Yeah, plant room. It's like this facility here we surveyed it within a day, and then to produce all the outputs, roughly, depends on where it is, but roughly we're talking 2,000, 3,000 for this, for all this information. They're kind of just ballpark figures. Okay. It's not hugely expensive in the scheme of things. And then if you want to do Revit modeling, that's additional costs on top. And in order to price that, it depends on if you want asset information embedded in it, depends on the level of LOD, but that could be, as an example, on this, it could be £4,000 or £5,000.
Okay, and I think another question that ties up with this is, in terms of regulations, special, any licenses or anything that needs to be obtained prior. How does this whole thing work? What do we need to do beforehand? Are there any additional costs to get any permissions and things like that?
Yeah. So when it comes to terrestrial laser scanning, there's no special permissions that are required. All you need is permission from the client to scan or survey the building inside or outside. When it comes to a drone survey, that's a bit different. We have a special license from the CA. It's called the PIFCO or an OSC, and that allows us to carry out operations essentially anywhere within the UK. We don't need permission from anybody to carry out those operations. Again, just the client. So we just need permission from the client to fly around their facility or fly around their assets. There are areas within London. There's 3 areas within London where you do need special permission. That's like Hyde Park, Square Mile, and Canary Wharf, and you do need permission from NATS to fly in those areas, and you need permission from the Diplomatic Protection Group, the Met Police, etc. But that's something that we would look after. So if a client comes to us and said, I need you to survey a roof in the Square Mile, we would look at the location and say, yeah, we can do this, but we're going to need permission from NATS, the Metropolitan Police, and the Diplomatic Protection Group. But we would organise all of that, get those permissions in place, and then we would kind of just factor that in as an additional cost. And then you just need to allow kind of an additional time as well, of probably like a week to 2 weeks to get those permissions in place.
Great. I think we can do one last question, and then anyone can send questions to you privately and directly. What's the future for drones, and any other concerns we should be aware of, especially from an FM perspective?
Yeah, I think the future of drones and terrestrial laser scanning and digital capture, I think, is really still in its infancy. And I think a lot of companies don't really kind of fully understand how this technology can be used. And this is a key kind of competitive advantage and a way for companies to kind of stand out and differentiate themselves from their peers. You know, there's huge productivity, time, and cost savings if this information is used in the correct way. And, you know, the regulations that the governments are bringing in to ensure that this type of information is handed over on projects. So, like, you know, a lot of clients are now looking for all types of, you know, digital BIM projects to be handed over as part of you know, new builds, refurbishments, etc., which is, you know, huge benefits to the clients. But again, I think the technology is going to be used more and more going forward, and yeah, it's great when it's used in the right way.
Great. Well, thank you. And if you go back to the introduction slide with our names, just so people can make a note and they can reach out to us with any other questions, you can find ProDroneWorks online, and then you can also reach us on LinkedIn if you have any question. You just want to have a chat. Thank you for your time, Ian, today. Thank you, Nicole, for organizing. And thank you everyone for attending.
Yeah, thanks Harry, thanks for organising the whole event, and thanks to everyone who attended. And as Harry mentioned, if anyone does want to get in contact about any individual projects they have, or any questions they have, they can get in contact with me directly. We have a website, we're on LinkedIn, prodroneworks.co.uk, or you can email me directly. It's ian@prodroneworks.co.uk. Okay,
thank you everyone. Hope you enjoyed the rest.